GitHub username is Yulia Zarina, and today is October 8th, 2025. The article that I'm referring to is Evil Eye Malware Masquerades as AI Tools to Infiltrate Global Organizations. Was made on September 29th, 2025 from thehackernews.com. The reason why I chose this topic because it's a perfect real-world example that ties together many core concepts from our course. While we learned about specific threats like phishing, social engineering, Evil AI shows their evolution. It uses sophisticated lures like fake AI tools that are far more convincing than a typical phishing email. Crucially, it exploits the trust model we've studied. The malware uses valid digital signatures from fraudulent companies, directly attacking public key infrastructure (PKI) and certificate authorities we rely on to verify software. Once inside, its objective connect directly to our lessons on authentication. By stealing browser data like session cookies and saved passwords, it can bypass strong multi-factor authentication and hijack user sessions. Finally, its techniques like AES encrypted command and control channels using legitimate frameworks show how threats hide from network defenses and behavior analysis, topics we've covered in encryption and malware units. In essence, Evil AI isn't just one vulnerability, it's a chain of attacks that show how all these security concepts are interconnected in a modern threat. This is a global problem hitting key industries worldwide. And what makes Civil AI so interesting to me is its method. It perfectly mimics real software, making it incredibly hard to spot. You can get in, hide, and set up a backdoor long before anyone realizes what happened. In this video, I'll explain exactly how this attack works, the technology it uses to stay hidden, and what we can do to stop something like it from succeeding. The first step for any hacker is getting their foot in the door. Evil AI does this through clever tricks that build trust. The malware is signed with what looks like a valid digital certificate. These certificates are bought from fake companies set up in places like Panama and Malaysia. Because the software is signed, it looks legitimate to users and even to some security tools, making everyone drop their guard. The working Trojan. This is a brilliant psychological trick. The malicious app you download actually works. It might be a functional PDF editor or recipe finder. This makes the user happy and eliminates suspicion. While the user is using the app, the malware is secretly active in the background. Once you run the fake app, it acts as a stager. Its job is to set up a secure connection to get the malware onto your system. Bootloader is a powerful backdoor. It gives the attacker remote control of your system. They can run any command, install more malware, or steal data. Reports show they often use this access to install software and for ad fraud. It lets the hacker run their malicious code using JavaScript, which can easily interact with your operating system to access files, run commands, and communicate over the network from what looks like a simple calendar or image viewer app. To hide this even better, they use Unicode homoglyphs. This means they replace characters in their code with lookalikes from different alphabet. This strict security tools that they rely on matching known malicious text strings. So why is this campaign so successful? The failure isn't one single thing, but a combination of problems in our defenses. We trusted signatures too much. We've taught ourselves that signed software is safe. Hackers are now buying those signatures for their malware, breaking that trust. Then apps actually work because the malicious app does what it promises. Users don't report it and it doesn't set off behavior alarms for being broken or useless. Next is too stealthy. The combination of checking for security software, using strong encryption, and hiding code with homoglyphs makes it very hard for traditional security tools to detect. It uses legitimate tools for bad things, By using a standard framework like Netralino JS, the malware's activity looks very similar to legitimate software, making behavioral analysis harder. Therefore, another engineering. In short, our defenses were tricked by a very convincing disguise and patient, quiet approach. Now, how do we defend against this? We need to be smarter about what we trust. Number one, be smarter about digital signatures. Don't just trust a signature blindly. Use tools that let you create a list of approved, trusted publishers. Be suspicious of new or unknown certificate authorities appearing in your network. Second, use application allowed listing. This is very powerful defense if you have a policy that only allows pre-approved software to run. These fake tools will be blocked immediately, no matter how convincing they look. Number three, focus on detecting bad behavior. Since the malware's look can change, we need to watch for its actions. Configure your EDR and security tools to look for software that immediately checks what security tools are installed, unknown processes making network connections using strong encryption, tools like Certidil being used to decode data, which is how homoglophs are often decoded. And four, train users on specific threat. Tell users that malware can now look like professional, signed, and fully functional software. Explain the importance of downloading from only official sources. And finally, number five, assume you might already be hacked. Hunt for these threats proactively. Look for network patterns linked to bootloader and for processes that seem to be using frameworks like Neutralino JS in suspicious ways. Finally, the ELAC campaign shows us that hackers are getting better at hiding in plain sight. They're using our trust and signatures and user expectations against us. By understanding the trick fake signatures, working Trojans, encrypted channels, and code hiding techniques, we can adjust our defenses to be more skeptical and behavior focused. Thank you for watching.